Hi everybody. I thought I'd talk a little bit about the progress I've been making with my lazy list library here and Go. Firstly, I've named it something sensible, and I've also put it somewhere sensible. So if we start a shell and do a git remote -v, you can see I put it onto what is that? Source Hut, where you can get it. Yep. Okay. Another thing, which I've been thinking, which I didn't do in the last video, so I thought I'd do it here, is I'd show you how it's actually used for more complicated things. As you can see here, I've made a benchmark for finding the. Let's see if we can read what it does. The first thing to do is here are the lines where the library is used, and let's try to parse these. You have to start in the middle, inside, and work your way out, which is one of the problems of this particular notation I've chosen. So you start by producing your generator, which is now called an interrange generator. Then you filter it using the filter function on isPrime. isPrime is just a simple definition of prime. Simple way to find if a number is prime or not. And then once you've filtered it for prime, you take the second item from the list, the first two items from the lazy list, and then you convert that to a slice. I move this function to the library because it's a useful function to have, and it works as well. And to compare it with a non-lazy evaluation, here I wrote the same thing but non-lazily. So it gets a list of integers, it checks to see if which integers are prime or not, puts them in a list of primes, and then it takes the second prime, and we can check to see how fast this is by calling go benchmark, and it works for a little bit. Then it tells you, it repeats it a certain number of times. You can see how fast it is. So the lazy method is a lot faster, which is understandable because it's doing much less work. Okay, I think this is pretty much all I wanted to say. No, there are a few other things. It would be one thing we could maybe do is change the turn this list into a struct with methods. At which point you could have a method on it called filter and a method on it called take, etc. So you could end up with something like range generator from 1 to 10 steps of 2, or whatever you want to call it. And then you'd have a 2 filter is prime. Then you'd be able to call a method take to be able to turn it into a list, or turn it into a slice, something like this. And at the top you would have a primes is equal. This would be another possible syntax we could do. And I may do this as well, because the syntax is a lot easier to read. It would be nice to use something like a threading macro as found in Scheme or Emacs. Let me show you what a threading macro is. Let's do a threading macro here. Let's require dash, because it's in the dash library, and then we can do something like let's take a list of 1, 2, 3, and then we can map on lambda x times x2, and if I got that right, that should give us, yes it does, give us 2, 4, 6. And then we can do something like filter. Have we got an even p? Got an even? Does that exist as a function? Doesn't look like it, so we'd have to create an even. Lambda x. I think we got a rem x2. Let's see. 0 rem x2. Does that work? Let's see. No, it doesn't like rem. Maybe it'll be a percent. Oh, sorry. Yes. Well, of course, that's going to be work because we've just multiplied by 2, multiplied by 3. We just get the 6 out. And the basic idea of this threading macro is you can just add things here to this column of actions. This is something you can find in Emacs Lisp with the dash library. It's something which is in a lot of Lisps. It's also in Clojure. The trouble is, what's the type of this? What's the type of this threading? You can imagine trying to build this in Go. And you'd start with a, let's get rid of this. You'd start with a func thread, which starts off with a list, which is okay. We can call that a list. That's not a problem. That exists. And then we have some list of transformations. Let's call that a list of T because we've now got a strongly typed. We've got we've now got generics in Go. Any, and then we would have to have a sort of list of things we want to do to the list, a list of functions to perform on the list, a list of actions. Let's call them actions. Which should be a action. And what is an action? An action is just something which takes a list of, takes a list and returns a list. So we have func which takes a list and returns a list. Now that's okay, but what's the type signature here? Well, the first one would take a list of T, but what does the second one take? What does it return? We don't know. If it was a filter, it would return a list of T, but if it was a map, it would return quite possibly something different. Which makes that it's difficult. I can't see a way to write this function in a type-safe language. Maybe someone, or in a strongly typed language. You can imagine that the compiler would know enough to check it. See, if you have a list of actions, the compiler could be clever enough to check, well, here you've got a filter for is prime, and you're doing a map with a toString or something, and you're doing a filter of larger than 3, and the compiler could check, oh, hang on, this isn't possible. But if you're passing all these things as a list to this function, to a function called thread, then I don't know a way to get the compiler to check that what comes out of one item in this list is the right thing to go into the next item in the list. And this makes it a bit more tricky. Certainly, it would necessitate implementing a syntax which is much more complicated than this nice simple syntax here. It's just an example of things which in strongly typed, which in explicitly typed languages are quite difficult to do. What else could I mention? Well, here I've added a partition in steps, partition with step, which was an interesting function to write. And I added a fold. So now it's fairly usable for pretty much anything you want to do with monoids and functors. I could add a flat map, couldn't I? Then I'd have a monoidic flat map. That's about it. Okay, many thanks. Bye.